Hi guys, today we are starting today we are starting 5 point Hi. Today we are starting 5.1, which is apply arithmetic with complex numbers. So let's take a second to talk about what a complex number even is to begin with. And we know that complex numbers are numbers where there is a square root is -1, or we see an I. So up to this point you guys have learned or probably been told that we cannot take the square root of a negative number. In a lot of ways, this is true. We won't get out a real number, but we can get out a complex number. So there's two main things that we have here. When we see the square root of -1, the answer of we can also write that as is I. With this, I squared is the same as square root of -1 squared. So it's a -1. So we're going to keep this in mind that now when we see negative numbers, we can write an I on the outside. So it kind of shows us here too with an A. Let's think it through with like the square root of a -5. So we can think of this as the square root of -1 times the square root of 5. I'm going to write that different. So instead of a -1, I write a I outside of the radical. So with this, let's go to the next screen. And practice it with just a simple -7. So try it on your own, rewriting this with a -1. So feel free to pause this, try this on your own. Wherever I see a -1, that can become an I outside of the radical. So square root of -1 became an I. If we looked at what this became for B, I can write this as a -1 times square root 18. It depends on how you learn to simplify radicals. I learned to think of this as a 9 times a 2. So I have an I, a 3, and a square root 2, or 3i square root 2. Another way you could have learned this is 18. I'm just showing another way. This is not the only way to think of it. So we could have thought of this as 2 times 3 times 3. And that means, oh, sorry, this is square root. So that means our square root would become an I. A 3 would get to come out because I could group it by 2's, and a 2 stuck on the inside. So that's another way you could have learned it. Either way you learn that is fine. The main thing we're focusing on here is with negatives and i's. Jumping down to C, this becomes just a -5. Because the square and the square root undo each other. So with this in mind, we reviewed what i's are. Now we can talk about what a complex number is. A complex number takes the form a plus b to the I. So a and b are like normal numbers, or integers, and i's are variable. I do not want you guys worrying about actually, sorry. If a equals 0 and b equals a number, then the number is a pure, what we call it, a pure imaginary number. So this could look like a 2i, or like a -3i. All of these have like an invisible 0 in the front, so that's what they mean by saying a is 0. So if we just have a normal number that's just an I, it's a pure imaginary number. Okay. So adding and subtracting complex numbers, so we add the real part, or we combine the real parts and the imaginary parts. By imaginary parts, we just mean the part with i's. So this is where we kind of treat i's like x's or other variables, in the sense that I'm going to rewrite my without parentheses. If it's helpful, write your real numbers by each other. Write your imaginary numbers by each other. And this is the idea of kind of combining like terms. So -2 plus 3 is 1. 4 minus 11 is -7. So I combined my like terms, and I combined it, which meant my i's could be added or subtracted, and my constants, normal real numbers, can be added and subtracted. Go and flip to the back page of your notes. Similar idea here. I just have to distribute this negative . So if it's helpful, rewrite it with your like terms by each other. So here's your constant, or your real number, and then there's your imaginary number. This one is similar. I just have to distribute this negative and then combine like terms. So at this point, our i's are really just like x's. So 4, 9, and negative 3. If it's helpful, rewrite it. With my real numbers and my imaginary numbers. And we end up with my real number and my imaginary number. Okay, now we're going to jump to where I has more than just to the first power. So far, most of the i's we've dealt with is I to the first. So this is just I. I squared, we talked about, this becomes square root of negative 1 squared. So that becomes a negative 1. This becomes I to the third. So that's the same as I squared times I. So negative 1 times I. Or just negative I. I to the fourth becomes I squared times I squared. So negative 1 times negative 1 equals a positive 1. My eyes look a little bit like Jay's. So we're going to use this when we start multiplying. We use the distributive property. And treat imaginary numbers as like terms. So basically it's really similar to x's still. Except now I have to do something a little bit with my exponents. 6i minus 10i squared. We know an I squared is a fair trade for a negative 1. So we just have to rewrite if we have something like I to a number that's not 1. We're going to see this in the next problem as well. You can use the box or double distribute. I'm going to double distribute. Off the bat, I see I can combine both of these. And here I have another example where I can rewrite so that's negative 12 times the negative 1, which is 30 plus 12. So I keep my constants or my real numbers and my imaginary numbers. So I am happy to help. When I'm back, feel free to email me with any questions. I will see you guys soon. Okay, bye you guys.